This is TWiT.
So in December 2015, an Uber driver ran a red light and crashed into a police cruiser, killing one of the passengers, Corey Allicock. Corey's brother has been coding since the 4th grade and says this accident didn't have to happen. Brian Russell Davis is a data science engineer, formerly at Pandora, and now the founder of Axiom 88, an engineering-first digital agency. Welcome to the show, Brian.
Hey, how you doing?
I'm good. Thanks for coming on. So you are working on a prototype for the dashboard that could tell Uber how often a driver runs a red light. Can you walk us through that a little bit?
Sure. So it's a really simple idea. The idea is that you place a small camera on the dashboard. Somewhere on the dashboard, I've been experimenting with all different positions of the camera. And basically what you're doing is you're recording the car as it's going through lights. And with a little bit of machine learning and computer vision and image processing, then you can really understand what the driver's habits are as far as those lights are concerned.
So do you have the prototype, or are you able to show us what you're working on?
Yeah, I mean, it's kind of hard here in the house, but I have...
You don't have a car in your living room? Come on.
Yeah, usually I do, but... this is one of the devices. Obviously, this is not the actual thing, because the actual thing's in the car, but this is an example. I'm not sure if I'm holding it up right.
Oh, perfect.
It's just a Raspberry Pi. This is the camera. You see how tiny it is. These cameras, when you buy them retail, of course, are expensive. But we've experimented with cameras that are as cheap as $2, and that's still retail price. You can get them even cheaper if you buy them wholesale, or just get them from China. So the other thing I want to show you is going to require a screen share. So should I try that now?
Yeah,
Sure.
If you can hop over, that'd be great.
So the first thing I want to show you probably is the video. So this is a really quick video, a piece of a video of me driving, and you see, it's just showing, kind of like the lights right in the middle of the screen. As I said, I'm experimenting with the position of the camera, and what I did is over here is I just grabbed 2 frames, one where the light is green and one where the light is red. And, you would probably think like, okay, this is a really hard problem to solve because, finding this little tiny light for the computer, for a program to find this little tiny light right here, it probably would be really, really hard. Oops, sorry about that. But it's not that hard actually. So when you think about it, what you need to do, first of all, you're gonna use computer vision to figure out where the cars are. So if I use some guides real quick, let's see if I can pull these down. There we go. So I use some guides real quick to kind of like mark out where the tops of the cars are. And then there's going to be a whole lot of white, like blue space above. So, and these lines, we can ignore those. So we can kind of like get to the tops of what would be considered the power lines, and then we can say within a margin of error that we'll just kind of like focus on the middle, so we can pull those out as well. So then, and I'm just doing this in Fireworks right now, but so then we have this really clean like idea of like these were where the lights are. Now I'm going to do another experiment here, and this is using a filter, a real quick filter. And of course, all this would be done with code and
that's all happening on the Raspberry Pi in real time?
No. It's not happening in real time.
Okay.
It's going to be, this is not a real time solution right now.
Okay.
This is a solution where it's crunching the numbers, and then it's. I'm not sure if you guys are familiar with TensorFlow. I imagine that you are. Mm-hmm. So what it's going to be doing is training a model.
Got it.
So then if I go into this filter, which is for curves, and I'm going to filter for red. It's going to take a second. Okay. And then I'm going to pull this over all the way over here. And you see that the green still shows up. So
okay.
All I need to do now is for that small little area that I showed you, and if I filter for red, then find out if there's a green circle inside there. And so the problem is significantly smaller now. Now, just to show you how it works over here, I'm going to cancel this and go over here to the red light. I'm not going to bother with, creating all the guides in the box and stuff like that. But then I'm going to adjust the color here for the curves. Then I'm going to filter for red. I'm going to pull this all the way over here. And then you see that, now, again, the problem is really simple now because all I have to do is make sure that I don't see those little green dots. And those green dots will show up as image data, which will show up as basically like color data to the computer. And so all the computer has to do is make sure that it doesn't see that in that area. And then what we do is we train the filter, and then we look at the results. We train the filter, look at the results over and over and over again until the algorithm gets better at detecting when a red light or a green light is there.
So you're training it against thinking that the brake lights on the back of the car is the same as a stoplight. No,
it's filtering out. It's filtering out it's filtering out the brake lights. So it's not going to see the brake lights. If a brake light is caught in the mix, and this is kind of a harder example because I'm really far away. You can imagine it will be easier actually when I'm somewhere like here. Okay, and it's a little out of focus. So now it's easier because this is like right smack in the middle. And then if this is a red light, or if in other words, there's another example that I had here. If this is a red light, then I know that I've ran a red light. Here, I went through a yellow light, and there was no red, and it was green right here. I actually ran this yellow light. See that? So I wasn't in the intersection yet, but it was yellow the whole entire time. So this is not an instant like, okay, give an alert kind of thing. It's a thing where first of all, we'll be tracking information over time to see the driving patterns of people's driving.
Of individual Uber drivers to know whether they are inclined to run a red light or to kind of obey these signals. So eventually something like this would be happening in real time. Maybe
I imagine that it could.
Potentially it could be integrated into the Uber technology. Uber has a lot of very knowledgeable, and very, talented engineers, let's say. Why do you think they haven't implemented something like this already? Because it seems pretty valuable to their fleet.
I think it's valuable in a different way. I think right now they're focused so much on, and I don't want to say too many. I mean, obviously my brother died. I could be very upset about that. But I think it's been 2 years now, and I'm trying to be very positive. I think that they're focused a lot on growth and expanding the amount of drivers and expanding the amount of riders and a lot of the resources to get put into that. Safety probably doesn't get as much attention. And what I'm trying to show with this is that actually there's a lot of easy fixes for safety that would make that can make an exponential difference over time. So that's one of them. You could also, in my article that I wrote, you can also monitor their speed, which is really easy with the accelerometer. You can also limit the amount of, this is one that can be implemented immediately. You can limit the amount of time that an Uber driver can drive. So in my brother's case, the driver, I think was 73 years old. And we know for a fact that, as you get older, your reaction time and, as far as driving is concerned, can be compromised. And over time, also with driving a long amount of hours, your reaction time can be compromised. So the thought here is that, number one, limit the amount of time that drivers can drive continuously. I know during the holidays that a lot of drivers will try to get bonuses and, they're trying to get, more money in order to buy gifts for their family, that kind of thing. But there's a certain point to where you're driving unsafe. And so that should be a really easy thing. After a certain amount of hours, I'm not sure what that amount is for each company, but I know for me, if I drive for 10 hours, then I'm pretty baked.
Yeah.
But also maybe that there is a visual test that can be done for all the drivers, and especially older drivers, that will kind of test their reaction time to see, if they're still within the safe limit of reaction time. Because really, a few more seconds of reaction time would have probably saved my brother's life.
It's amazing to me that they're not doing that, especially the hours. I mean, I know truck drivers are only allowed to drive certain hours, but
right.
I think it's a good point that they are very focused on growth. So this is kind of a family project that you're working on. Your son has a project that's different, but you're using that. Can you talk a little bit about how those two have come together?
Yeah, I'm so proud of my son. He's a senior at Morehouse College in Atlanta, Georgia. He's a math major. Ever since his freshman year, he's had an internship at Rockwell. So he's going to come out of college with a job in mechanical engineering. And a few years ago, well, no, it was about a year ago, I asked him, I said, hey, have you invented anything lately? And he said, well, yeah, I've invented this optical switch. And I was like, oh, this is cool. So I had a friend who was a nuclear scientist. Don't ask. That's a long story. But him and Caleb got together and devised the simple device that can detect gamma radiation. So it's just, a switch is just kind of like, it's telling if something is off or on. And the optical part of it is what makes it so cheap, is because basically it's just light. And so Caleb would have to explain it, but basically all it does is it detects whether or not that light has been split by a particle of gamma radiation. And he presented this at the American Nuclear Society conference in Vegas. It was also around the time of his birthday, so that was kind of perfect timing. And a lot of people were impressed by it. It was really great, really great.
I'm curious to know how you feel. I mean, I feel like the story around Uber often kind of ventures into the story, this like growing trend towards autonomous vehicles.
Yeah.
And what you're talking about, the technology that you've been working on, is really geared towards actual human drivers and not machines, not robots driving the cars. Does this shift towards autonomous fleets, does that give you hope for the future of auto safety compared to kind of what we've grown accustomed, what we're used to now?
Right. So when you think about it, the autonomous fleet already has this technology.
Right.
It already has to sense a red light. So all I'm asking is that we miniaturize and that some of that technology and make it available for regular drivers. But yes, the autonomous cars already have this technology built in, and I'm sure there will be, they're testing it to make sure that they save people's lives, don't endanger anyone's lives there. And I guess what I'm saying is that it's kind of the opposite. Is that the technology that's being kind of sunk into this autonomous model should be also kind of retroactively looking at people who are actually driving real cars.
Right, and if it's a Raspberry Pi and a $2 camera, it's something that's affordable. It's not crazy expensive technology either.
Right. I mean, and think about it like you can mount your phone on right in front of your dash, and so maybe that's part of it as well. You don't even have to buy a new camera. You can use the camera that's right there on your phone.
Yeah, good point.
Well, Brian, thank you so much for joining us. Brian Russell Davis is a full-stack dev engineer with 17 years of experience. And tell us a little bit about Axiom 88. That's the company that you founded. What do you guys do?
Oh, sure. Yeah. We do a lot of stuff, mostly these days on data science type stuff. So I've done a lot of work for military intelligence and analyzing threat data. I worked on something called Arc Live, which is basically like a Jason Bourne Google traffic maps for like terrorist threats. And Also, I've built apps and stuff like that and websites, so it doesn't have to be, that scary.
Well, thank you so much for joining us. Take care.
Well, thank you very much.
Yeah, best of luck with your project.
Bye-bye.
Appreciate it.